The mass spectrum for a molecule that contains carbon, hydrogen, and one other element is shown below. What is the most likely identity of the third element? So we know that this molecule is an organic compound that has just carbon, hydrogen, and one other element. And we're also being told that where the molecular ion is. So we're being told that this peak at 156, so that's the M over Z value, the mass to charge ratio here on the bottom. So that peak at 156, we're being told that that is the molecular ion. So that is the M plus peak. So what we're seeing here is that that is actually not the heaviest peak in this spectrum. We're seeing that there is another peak here at 158, so 2 mass units heavier, so we call that an M plus 2 peak. So we will see this for certain molecules that have 2 isotopes, naturally occurring isotopes that occur in a large enough amount that we might be able to see it in the mass spectrum. So our options here are either bromine, chlorine, oxygen, or sulfur. So what we want to know is what are the major isotopes of these elements and approximately in what ratios do they occur. So if you're looking in your textbook for this class, we can see the natural abundance of some isotopes in table 13.2. Okay, so if we take a look in there, we're going to find out that we have bromine 79 and bromine 81. And if we look at the table, we're not going to write down the exact value. These both occur in roughly 50% abundance. Okay, and so we've got bromine 79 and then 2 mass units heavier. So that's where we'd have the M plus 2. So all of these are going to have isotopes that are 2 mass units apart. So if we take a look at chlorine in that same table, 13.3, we're going to find out that we have chlorine 35 and chlorine 37, and that we've got somewhere around 75% of chlorine 35 and about 25% of chlorine 37. If we take a look at oxygen, we're going to find out there's actually 3 different isotopes, oxygen 16, 17, and 18, but we're going to focus on the 2 that are 2 mass units apart. So most of our oxygen is oxygen 16, almost all of it. Actually, I'll give you the exact values this time from the table, 99.76%, and oxygen 18 at 0.20%. Okay, and then we'll take a quick look at sulfur. And then we're going to see what can we do with these numbers and how we can match it up to the mass spectrum. So if we look at sulfur, we have sulfur 32 is our major isotope of sulfur at about 95% of all naturally occurring sulfur. And we want to look at the one 2 mass units heavier, so we're going to look at the sulfur 34, and that's at about 4.2%. Okay, so what we're seeing here in our actual spectrum, we're seeing that these 2, the molecular ion and the M plus 2 peak, that these are roughly equal in height. So what that tells us that there's about an equal chance of the molecule hitting the detector with this isotope as there is with the second isotope that is 2 mass units heavier. That's only going to happen when you have about equal amounts of those 2 isotopes. So that's what we're looking at here. We're looking at bromine. Okay, and we can see out of these options, these elements that we see all the time in organic molecules, only chlorine and bromine have a significant amount of that heavier isotope. If we look at oxygen and sulfur, these are really low percentages. We're going to be hard pressed to see those peaks because you just don't have very many molecules containing those. So what we're going to focus on is bromine and chlorine. So when you've got that M plus and the M plus 2 peak roughly equal in height, that tells you that you have bromine. Okay, if that M plus 2 peak was roughly 1/3 the height of the molecular ion, that's what you would see for chlorine. That would tell you that you have chlorine. So it's really chlorine and bromine that we are going to be focusing on.